Hello everyone, my name is Ben Eady and I'm the Online Media Manager for ModernAnalyst.com, the premier online community for business analysts. I'd like to welcome you to today's webinar titled The Use Case Technique, an Overview. Today's featured speaker is Carl Wiegers and Martin Pedersen. The webinar will last approximately 60 minutes, including the Q&A session. So make sure to submit your questions in advance using the question feature on the webinar software. I'd also like to say thank you to RequirementOne for sponsoring this event. And at this time, I'll turn it over to Carl and Martin to get us started.
Sure, let's get started. Well, first of all, hi everyone, and welcome to our webinar about use cases. We really hope that you're going to find it useful. I'd just like to give you a quick introduction to RequirementOne. We offer 5 integrated apps allowing you to maximize productivity and success of your projects. The most relevant app for today's presentation is the Specification app, which allows you to manage all of your requirements, use cases, and tests in one place. The charge is just $45 per month for this product per project with no per user fee and no upfront cost. The important thing to point out is that RequirementOne supports all of the recommendations that Carl is going to walk us through today. So putting his recommendations together with our product will really help you run successful projects. So at the end of this webinar, we put together an offer that if you sign up for a free trial by August 1st, we'll provide you with an exclusive training session that will show you how you can put past recommendations through RequirementOne into place in your project. And on that note, I'd like to hand it back to Carl, and I hope that you'll enjoy the webinar. Have fun.
Thanks very much, Martin. Greetings, everyone, from sunny but not too hot Portland, Oregon. We feel sort of sorry for those of you who are baking in much of the rest of the world, but we're not supposed to tell people how nice it is here during the summer, so you didn't hear that from me. Thanks very much for joining us today. This slide shows a little bit of information about me. There I am, and contact information, and also shows some of the books that I've written. Let me point out my most recent book, the one on the right, which is a memoir of life lessons called Pearls from Sand, How Small Encounters Lead to Powerful Lessons, rather a departure from my previous software books. For several months now, I have also been writing a consulting tips and tricks blog that I've listed here at the bottom. And even if you're not a consultant, there's a lot of good information there about writing and giving presentations and other aspects of what we do as professionals. You might want to visit the goodies page at my website, processimpact.com, the URL at the bottom of this slide, where you can download a wide variety of templates and other useful work aids. You know, I've been thinking about how to improve requirements practices on software projects for more than 20 years, and I became a fan of the use case technique and related methods when I first applied use cases with great success to a project called the Chemical Tracking System that I worked on at Kodak. If any of you have seen my software requirements book, then you've bumped into some information about the Chemical Tracking System. It was a real project we worked on, and I really became enamored with use cases on that project because it really provided a much more powerful technique for requirements elicitation than any other method we had used before. So today I want to share with you some of what I've learned about this particular technique and hopefully get you excited to learn more about it and see how it might work for you. There's various places you can learn about these, of course. This is the Software Requirements 2nd edition book that I wrote a few years ago. I've got a whole chapter on use cases in there that provides a nice overview of the topic. And then in my later book, more about software requirements, I've got some chapters which deal with some of the trickier, more confusing aspects of use cases where I've seen people struggle and have struggled myself at times. Some of these I'll be talking about a little bit today, things like actors versus users, requirements, or I'm sorry, use cases versus scenarios, when use cases really aren't enough for your requirements projects, and so on. So these are both pretty good resources. Now, a wise man once said to me, if you read one book on use cases, you're in good shape. If you read more than one, you're in trouble. And he really has a good point because there's maybe a dozen or so books out there on use cases, just focused on that topic. And they're a little bit different. It's kind of been an evolving discipline, and the writers in the field don't all agree exactly on vocabulary and conventions, even though they're all talking about the same kind of thought process and the same general method. So I'm just going to present here in my short talk today and in my other writings and presentations and courses on this, I present a mainstream approach. This is not Carl's wacky new method for use cases. This is a very mainstream approach that's combining what I found to be the most practical and sensible of the ideas out there in use cases, shaped by my own personal experiences and those of other people I've talked to. Now, if you did want to read just one book on use cases, this is the one I suggest. Use Cases, Requirements and Context, 2nd edition, by Daryl Kulak and Eamon Guiney. By and large, I think this is a very readable, very practical, and straightforward book that you'd find as an easy way to kind of get into learning more about the method. Well, I can't tell you everything there is to know about use cases in this brief presentation today, just give you a solid overview of the method. I do have a nice e-learning class called Exploring User Requirements with Use Cases that you can access from the e-learning page at processimpact.com if you wanted a more comprehensive treatment of the subject. That's basically a one-day class. So these are the topics that we'll be covering in this webinar. First, we'll start with a definition, kind of let you know what, at least how I think about use cases and how that fits into an overall model of different kinds of requirements information. I'll share some of the benefits I found of the use case approach and why I have really felt that this is an effective technique for many kinds of projects, but not all projects, and I think that's important to keep in mind. I'll talk a little about the relationship between user classes and actors, two related but not identical ideas, and similarly how scenarios and use cases fit together. I want to tell you a little bit kind of in a case study about how I actually applied this method with some colleagues on that chemical tracking system and other projects when I was working at Kodak and thereafter. I'll tell you how I kind of structured the elicitation workshops where we would sit down with some users and other stakeholders to try to start gaining an understanding of what their use cases were. Now, if you just go up to your users, suppose you're a business analyst, and you say to your users, okay, we would like to talk about use cases today, they're not going to have any idea what that means. And so it's your responsibility to educate the people you're working with so they can have an understanding of what this is all about and why you're taking that approach, so they really know what kind of a mindset to have that leads to the useful conversations. So I'll tell you a little bit about how we approach that. I'll describe the kind of information that I think is useful when you're describing or documenting a particular use case, and also then wrap up with some thoughts about the relationship between use cases and functional requirements. And I think this is an important point. You don't actually implement use cases. You implement little fragments of functionality that let developers know what to build and let users do certain things with the software. So use cases help us figure out exactly what functionality that we do need to build. So these are the topics I'll be covering in this presentation. There are a lot of different ways to think about requirements, and I've put together a little three-level model I want to spend just a few minutes talking about here to help you see at least how I think about different kinds of requirements. You know, I could show each of you one requirement statement and you would all call it something different. Someone would say it's a user requirement, a customer requirement, a stakeholder requirement, functional requirement, system requirement, software requirement, a feature. We get all this terminology problem. So at least for the next hour, I want to have a more common set of terminology amongst us, and so that's what I want to introduce here. I like to start at the top with business requirements. Now, when I use the term business requirements, I'm talking about information that answers the question of why are we undertaking the project? What are our business objectives that we're trying to achieve? And that's not enough information for people to know what to build, but it's an important starting point. And I like to capture that in a vision and scope document. People create various kinds of guiding documents for projects. They might create a project charter or a marketing requirements document. And this is the same kind of thing, some top-level strategic, usually relatively short document that talks about why we're undertaking the project and what we hope it's going to do for our business. Now, when I say documents here, it need not be a traditional word processing document. I'm really talking about it as a container for a certain kind of information. So business requirements answer the question why we're undertaking the project, but that's not enough. We need to know also what do users need to be able to do with the system, and that's what user requirements are about. Sometimes these are called stakeholder requirements. I've used the term user requirements for some years. So this is really where use cases fit in. Use cases are a very effective way for many types of projects to capture the user requirements, to answer the question, what do users need to be able to do with the system? What are they trying to accomplish? And so that's really what we're going to be focusing on here today. But I've found that a lot of people have had problems. I do little surveys in my presentations and the classes I teach, and very often people have told me, yeah, we wrote our use cases and we gave them to developers, and it gave the developers an understanding of what we were trying to do, but there was a lot of information missing. There was a lot of detail that they had to go chase down or ask questions. And so what I realized is that use cases simply are not enough information in most situations for developers to know what to build. We need to go down to the third level of functional requirements. And functional requirements make up, in most projects, the largest portion of a software requirement specification, or SRS. So these three containers, a vision and scope document, use case document, and SRS, are three kinds of key information that most projects need to make sure that we build the right system that lets people get things done. Now, of course, there's a lot of other kinds of requirement information, and so this model is not complete. There's an important thing to keep in mind about models also. All models are wrong, but some models are useful, and I think that applies here as well. So some of the other kinds of things we have to deal with in doing requirement solicitation are business rules, policies, and standards, and things like that, which can influence both use cases and functionality. Quality attributes, often called the ILITs, such as usability and portability and maintainability and dozens of others, are a critical aspect of non-functional requirements. We need to understand external interfaces between our system and the rest of the world, and we need to understand design and implementation constraints that developers have to respect. So all of these kinds of information feed into this body of knowledge that we call the requirements. Now, there's nothing that says you have to get all of this at the beginning of the project and then just go off and build your software. As we all know, the pure waterfall approach doesn't usually work very well. But these are the kinds of information that you tend to accumulate over the course of the project. So what I'd like to do today is just focus on this middle level here of the user requirements, and most specifically employing the use case method as a way to reach an understanding of what users are going to try to do and accomplish with the system. So use cases are not a new technique. They've come out of the object-oriented world, developed in the 1980s or perhaps even earlier, but people have been using the related technique of understanding user scenarios for many years. And even though this came out of object-oriented thinking, it really applies to general requirements analysis for a lot of different kinds of systems. Use cases are an example of a structured technique for eliciting requirements from a group of users. Perhaps the worst question you can ask during requirement solicitation is, what do you want? Perhaps another very useless question is, what are your requirements? People don't really know how to answer those kinds of questions, and so you end up getting bombarded with a variety of random but important information, and you really don't know what to do with that. And use cases provide a structure that helps us have more effective communication around those kinds of issues. So this is a method to capture that second level of requirements I mentioned, the user requirements. What we're trying to do is focus our attention on actual but abstracted, that means not overly specific, usage scenarios. As a business analyst, I'm trying to get into the heads of representative users that I'm working with to understand what they're trying to accomplish and maybe even how they envision interacting with the system in some sort of a dialogue to reach that useful outcome. So really, the essence to me of the use case method is a change in the conversation. Rather than asking people, what do you want, or what do you want the system to do, I don't really care about what we want the system to do. I want to know what the users need to do. So we change the question in a small but very significant way. We ask things like, describe a goal you wish to accomplish with the system. Another way to think about it is, if a user sits down at their computer and fires up a particular application, why? What are they trying to do during that session? So those what are you trying to do kinds of thinking is a way to understand their use cases, their cases of usage, literally. So a little clue that when you're having a requirement solicitation discussion with someone, a little clue that they might be telling you about a use case is when they say something like, I want to, or I need to be able to perform some task. So whatever follows that phrase, I want to or I need to be able to, is often going to be the name of a use case. So use cases provide a user-centric approach, focusing on what users need to accomplish, and then the business analyst can then derive the functional requirements that will let the system allow the user to accomplish those tasks. So once we have a general understanding or a list of what these use cases might be, then we can explore each one, perhaps to different levels of detail. I'll talk more about that later, to try to understand a sequence of actions between an actor. An actor, for today's purposes, an actor is pretty much a user, but that's not exactly correct. But an actor is something outside the system that's interacting with it, usually a person, but not always. And some sequence of actor actions and then corresponding system responses, some kind of a dialogue or conversation that takes place that hopefully results in the user accomplishing what they're trying to achieve. So from that information, we can accomplish a lot of good things. We can get a lot of information. We can get information about the functionality that has to be built in order to let someone do these things, or accomplish this goal. And this was a real eye-opener for me the first time I did it, the ability to start writing tests from our use cases very, very early. I think we've all learned, and certainly one of the focuses of the Agile movement in the last several years has been to use test thinking as a way to drive a lot of the development work. And use cases accomplish that beautifully. We can start thinking about how we would test our system long before we've ever written a line of code, just conceptually. And that's a very, very powerful technique. So I'll say more about that as we go along here. So let's look at a definition here of what use cases are and also what they aren't. A use case is literally a case of usage of a system, which allows the user to achieve some goal that provides value. So here's kind of a formal definition. It's a description of a set of interaction sequences that a system performs to provide a result of observable or measurable value to one or more actors, where an actor is some entity outside the system. So this idea of value, of some useful outcome, is very central to the notion of a use case. So a use case should be some kind of a standalone activity. The actor has some goal in mind, they walk up to the system, they interact with it in the form of some use case, and if all goes well, they accomplish their goal. Any system property that does not describe a user goal is not a use case, although it could perhaps be a part of a use case, such as a step in the dialogue, or maybe a rule that has to be followed to constrain certain aspects of the dialogue. Now, there's a trap to watch out for here that I see a lot of people falling into. Now, I personally believe that not all of your requirements need to fit into a use case. In other words, I view a use case as a technique for eliciting and understanding the functional requirements. So therefore, I don't feel a need to make all my requirements fit into little use case packages just so I can say they're there. So for example, the classic error I see in this is logging into a system. Sometimes people will say, okay, logging in is a use case. And then I ask myself, well, what value does it provide? Nothing. No one ever walks up to a system with the goal in mind of logging in and then saying, okay, thanks, that was great, and then walking away. It doesn't provide any value in itself, although logging in is certainly a prerequisite for delivering value to the user. So even though we absolutely have to implement functionality to let people log in and have appropriate security and change passwords and all that kind of stuff, that's critical, but it's not a use case. And so this is one reason why I say you don't have to try to force fit all of your requirements, your functionality, into use cases. It's a very common trap. So use cases typically describe user goals or objectives. They describe the user's view of the system. We want to write from the perspective of the user and not the perspective of the system. It's another way to think about this is it's a set of task-related activities that help you accomplish some business objective or other useful outcome. For example, okay, I'm flying someplace this afternoon, going to fly to Boise and visit my mother, and I printed out my boarding pass this morning. So that was my use case for accessing the Alaska Airlines website. I wanted to go in and print out my boarding pass and went through some dialogue with the system to accomplish that. And once my boarding pass appeared on my printer. I said thank you, and that was the end of the use case. I walked away happy. I reached my goal. But a use case is not the only way to represent requirements information. People sometimes ask me, how do you write requirements so users can understand them and so that the developers get the detail they need? And this is hard to do. A lot of times, one single representation of requirements doesn't meet all of your objectives for both the users and the technical views of the system. You might need multiple representations. So the use cases then focus on the user view. Now, what use cases do not describe are things like user interface designs. And when I'm talking about use cases, I don't even like to use UI language. I don't want to even say, click on OK. I would rather abstract that into submit. Okay? So instead of saying user clicks on OK, I would rather say user submits the entry. And that may seem trivial, but what that does is it avoids getting you painted mentally into specific user interface interactions prematurely. What if you're at a touch screen? You don't click on OK, you touch something. So I don't like to talk about specific user interface components in use case discussions. We don't want to talk about technology solutions or architecture of the application, those kinds of internal things, because users don't care about that stuff. Users care about what they're trying to do with the system. So let's watch out for that trap of putting technical and implementation detail into the use case. Now, people often wonder about the relationship between use cases and user stories, and I was actually reading some debates and discussions about this online yesterday. And I think people get way too wrapped around the axle about this. User stories have become a popular requirements construct in the Agile development community, and I don't really see them as being substantially different from use cases. I think in both situations, what we're trying to do is capture an understanding of what users are trying to accomplish and then how they might accomplish that. So it's really a continuum of information. The user story might just be a statement of the user objective at a fairly high level, so you know who's trying to accomplish what and why. That's very helpful. A use case then starts with that and then goes down into some level of detail to perhaps get a more detailed or more specific concept of how the user might interact with the system that leads to achieving that objective. So it's perfectly fine for you to document your use cases at varying levels of detail. We don't have to completely fill out a rich template, nor do we have to limit ourselves to just a short sentence about it. You have to just use a lot of judgment and common sense so that you describe your requirements in just enough detail to effectively and clearly communicate to those downstream who need to do necessary work on that set of requirements. So this might mean going down into a lot of detail in certain cases, and then for other well understood or simple use cases, you can maybe get away with a more general high-level statement like a user story and just let the developers flesh that out in real time as they go along. So don't get too wrapped around the axle about that. I just think of them as a continuum. And a little bit later, I'll show you what kind of information you might put into a rich description of a use case. And it's up to you to decide in each situation, how much of that detail do I need to minimize the risk of somebody going in the wrong direction and having to do rework. I see a lot of benefits from the use case approach. Traditional requirements gathering processes often emphasize system features, but in contrast, the use case approach emphasizes user goals. It's user-centric, not product-centric. And so we're using the user's terminology and trying to write requirements at this level in a way that our users will understand. In fact, if you write a use case and your users don't understand it, they can't figure out what it's about, then there's something wrong because it ought to speak to them. They're also task-centric. It helps us understand what functional requirements we need to implement to let people get the work done. This is a way for the analyst to better understand the application domain because the requirements discussion is focused on the kinds of tasks users have to accomplish, perhaps in the course of their business day. One of the real advantages here is that this helps us avoid building unnecessary functionality that might have seemed like a good idea at the time, but no one ever uses it. It doesn't add value to specific tasks. I suspect you've all worked on projects where people ended up requesting certain functionality and you built it and nobody ever used it, which I find extremely frustrating as a developer. I could have spent my time doing other things that were much more useful, perhaps. So use cases help avoid that because the functionality we derive from the use case is clearly related directly to people accomplishing certain tasks. Again, I really want to stress the value of starting to write functional tests, conceptual tests early in the process. So you can start testing your software right after writing your first requirement here, because you can think about how would I tell if this was correctly implemented. That doesn't mean you're wasting effort. It means you're reallocating effort during the life cycle. And every time I've done this, I've found it to be valuable. We also can employ use cases to help us set the implementation priorities on functional requirements. The requirements that come from the high priority use cases are probably higher priority to implement than something from a low priority use case. A use case could be of high priority because it's a core function of the system. Maybe it will be used frequently or by many users. Perhaps it was requested by one of your favored user classes, or it might be required for compliance with some business rule, standard, or government regulation. So this helps us know just which of our many fragments of functionality will be most important to implement in the early stages of our project. Use cases are appropriate for many, but not all situations. They work very well for most any end-user applications, the kinds of things we are typically used to employing on our desktop. They work great for websites. I've employed the use case technique on a website project when I was at Kodak, and it was just a very natural fit. And in that particular project, we really stopped at the user story level. We didn't go down into detailed use case descriptions, but the advantage of thinking about what would people want to do at this website was very powerful to help us focus our application development on what we knew people needed to do. Nobody cares what you can put on your website. What they care about is what they can get from your website or do at your website. So that's the difference between a user perspective and a system perspective. They also work well for devices with which users must interact, like kiosks, for example. You know, if you're buying a subway ticket in New York City, or if you're checking in at the airport, you're using a kiosk most of the time, and those kinds of machines, use cases work well for those. Use cases, however, are not as valuable as an elicitation device for certain other kinds of projects. They don't really help you much with batch processes or computationally intensive systems like modeling or data warehouse applications, for example, because the complexity of those applications doesn't lie so much in the user interface dialogue. It lies more under the hood. And so use cases don't help a lot with that. Use cases aren't particularly valuable for event-driven real-time systems either. Sometimes an event response table is a better way to identify user requirements, especially when the user is not a human being. And a good example of a system for which use cases aren't adequate is, say, a complex highway intersection. I can only think of a handful of use cases. For cars, you want to go through a green light, turn right or turn left, and if you're a pedestrian, you want to cross the street. So those are really the only use cases I can think of for a highway intersection, but still there's a lot going on, and that's not enough information for a developer to know what to build. It's more valuable to think about events that take place that the system must respond to, like cameras or highway sensors that detect vehicles, buttons that are pressed across the street, timers, and so forth. So don't think that use cases are the only tool you want to apply for requirements elicitation. So, all right, now that I've said use case 1,000 times, here's a few simple examples of use cases from various kinds of projects. When I started out as a consultant, my accountant and my lawyer both said, hey, go buy QuickBooks. Intuit QuickBooks is an accounting application for small businesses, and I didn't and still don't know anything about accounting, but I find QuickBooks very helpful, and here are some of the accounting tasks a business owner might need to do with such a product. They call these activities in QuickBooks, and they're things like write a check, or enter a credit card charge, or create an invoice, and maybe if you create an invoice, someday you can receive payment. So these are all things you would want to do, and these are stated on one of the QuickBooks menus, and they are very good examples of use case names. And you can think of why you might want to interact with QuickBooks someday to do one of these things. You know, if I get a check in the mail today from a client, I'm going to fire up QuickBooks and use the receive payment use case to enter all of that information. Now, pretty much everybody has ordered things from companies like Amazon.com, and if you order something from Amazon and you get an email saying, hey, thanks, we'll send you your stuff, and in the meantime, here are some things you can do for that order. You can check the order status, cancel unshipped items, change your shipping options, or track a package that's been shipped. So these kinds of things are also use cases. Those are all things you would do with a particular, in this case, a website. Now, another way to think about this is, I think, helpful here. Suppose you were buying a product online just generically. Here are some of the things you might do. You might search a catalog for a particular product. You might place an item you're interested in your shopping cart. You might pay for the items in your shopping cart. Or you might chain all of those together into one larger use case just called buy a product. Now, here's an important point. If these are all things that a user could do independently, like the only action in a single session of the application was to search the catalog, or the only action was to place an item in the shopping cart, then those would all be individual use cases. But suppose you could only do some of those things together. Like maybe you have to search the catalog before you can put an item in your shopping cart. Then I would not treat those two as separate use cases, because they can't be done as both standalone things. You can't just place an item in the shopping cart in that situation. So that's an important idea to keep in mind, is that we need to keep these things as independent standalone tasks. And notice the task-centric perspective for all of these statements. You can clearly see that there's a goal the user has in mind. Now, one of the things that people pretty much all agree on regarding use cases is how to name them. So the properties of a name should reflect the actor's goal from the actor's perspective, not talk about things the system is doing. We're talking about what the actor wants to achieve. They should clearly describe some transaction that provides value to an actor, and the name should be general enough to cover a number of logically related scenarios. If you have very precise names that are overly specific for certain variations of a task, then you end up with this use case explosion where you have lots and lots of similar use cases. You really need to abstract those and be a little more general, certain groups of them, so that they're related variations on a theme. So this shouldn't be just a step in the process. Like if you're using an automated teller machine, one of the things you often do is select the language that you want to use for the dialogue. Well, that wouldn't be a use case. Select language is not a use case. You never go up to an ATM and so that you can just select the language you want to use. So that's just a part of a use case. So we would write these from the actor's point of view, not the system's. So, for example, again with an ATM, you might say withdraw cash, because that's what the actor wants to do. You would not say dispense cash, because that's written from the system's perspective. And I don't really care if the system goes away happy from a use case. I care if the user does. So the standard way that you name use cases is that they always start with a verb, some kind of active, direct verb, followed by an object, and some other adjectives can be fine there if you want. So you might say generate usage report. Generates a verb, and the object is usage report. So you wouldn't say usage report generation. That's not proper phrasing for the name of a use case. We want to use strong, focused verbs and specific nouns. We want it to be as precise and clear as we can. So remember, the use case names often complete a statement like, the system must provide the ability to, or I need to be able to. And you can see that all those use case names we saw in the last slide would answer that question or complete that sentence very nicely. Try to avoid using weak generic verbs like process or enter or manage. Sometimes those are the right ones, but a lot of times we want to use something a little more specific. So here's some examples of, I think, fairly good use case names. Reserve a rental car, print an invoice, check flight status. Those are all, I think, very clear, direct statements of objectives. Here's some examples that aren't such good names. Enter a PIN. Well, that's not really a use case. You don't just enter your PIN and that's the whole transaction. That's part of some other transaction. Submit a specific form. What if you've got 100 forms? You probably don't want to have 100 use cases that all say submit form, XX. That's into the use case explosion problem. Process deposit. That's kind of interesting. What exactly does process mean? And that verb is, or that name is a little clumsy for another reason, because both process and deposit could be either verbs or nouns, so it can be kind of confusing to know exactly what that one means. So this idea of naming use cases by always starting with a verb is an important convention. Let's talk about user classes and actors. User classes represent distinct communities of users for the product. They're groups of people or even non-human users who receive systems or services from a system. Actors are roles that those people can play with respect to the system. So they're entities outside the system that interact with it across the system boundary for the purpose of completing some sort of a transaction. So users are real. Those are real people or real things or other systems, but actors are just abstractions. So sometimes members of one user class can perform several different actor roles at different times. Here's kind of how I think about it. Let's say we had a banking application, and we have a class of users called bank customers. Okay? Now, depending on exactly what the bank customer is doing at any particular time, they might be acting as an account owner, so that the system sees that the account owner can do certain things with the bank. Or other times, that very same human being, bank customer, might come in and apply for a loan, in which case they're a loan applicant, or maybe they're just depositing a check into their company's or their spouse's account, in which case they're a depositor. So these are various roles that they would have to perform at different times. So I like to think of a member of a user class as being able to wear several different hats, one at a time, each hat labeled with whatever role the user is performing during a specific session with the application. And each of these roles is an actor name. It can work the other way too. On our chemical tracking system, we had several user classes that I've shown here: chemists, chemical technician, people who worked in the chemical stockroom, and lab managers. And one of the things all of these people could do is request a chemical. So as far as the system was concerned, when someone's using a use case to request a chemical, all they know is that person is acting as a chemical requester, and they don't really know what their job title is or what their user class is. So I think there's kind of a many-to-many relationship here between user classes and actors. So notice that the actor names often end in ER or OR, which indicates someone who's trying to accomplish something with the system. Another point of confusion that comes up sometimes is scenarios versus use cases. We can think of a scenario in a couple of ways. It could be thought of as one specific path through a use case, or we could think of a scenario as being a story about a specific instance of a use case execution, maybe with identifying actual users and specific data to make it a little bit more precise. So a scenario is less abstract than a use case, or conversely, a use case encompasses multiple scenarios. These could be successful scenarios, like the most typical path through the use case is typically called the normal flow or the normal path, or the happy path that has many names. The main success scenario is the sort of the default or most typical way that we would use the use case. But we could also have scenarios that result in failures. In other words, we are unable to successfully accomplish the interaction. So the way I think about this is that some user has an idea, a goal in mind of what they want to accomplish. They go up to the system, they choose one particular path through the system's use case, and they achieve their goal if all goes well. So that's kind of the relationship between scenarios and use cases. Another way to think about this is in terms of levels of abstraction. Let's suppose we have a company called Postal Delight that handles all of your shipping needs. Let's consider the act of preparing a mailing label for a customer's package. And we can imagine a set of scenarios that cover the spectrum of abstraction. The most abstract scenario, prepare a mailing label, would be a good name for a use case. Okay, so if you're talking to employees of a Postal Delight store, building a new system for them, and say, what are some things you'd need to do with this new software? They'd say, well, I need to prepare a mailing label. You can see that I need to just flows off the tongue very naturally. So that's a good name for a use case. And that would encompass any conceivable package that a customer might want to ship, any combination of origin and destination locations, and all variations of shipping methods, prices, and so forth. Now, a slightly less abstract scenario would cover a specific shipping method. I want to prepare a mailing label to send a package by second-day UPS. And an even more specific scenario would be a little story about a particular customer with a particular need. Chris wants to send a 2.5-pound package by second-day UPS from Portland, Oregon to Rochester, New York. She wants it insured for $75, and she wants a return receipt. The package is marked fragile. So you get a little story like that, and that's a very good way to kind of start getting into people's heads about what are their use cases. And you might start with some stories. Tell me about the last time somebody came in and wanted to ship a package. So that's a nice little story. And then you can move up and down that abstraction scale. I think one skill of an effective business analyst is the ability to slide up and down the abstraction scale as appropriate. Sometimes you start with scenarios and then slide up the scale to generalize to a broader use case that covers a wide range of similar scenarios. But sometimes you start with a use case and then drill down into it so that you can understand, some of the various specific scenarios that will help you flesh out your understanding of the use case and test it. So that idea of a sliding scale of abstraction, I think, helps us understand scenarios and use cases as well. All right, let me tell you a little bit about how I actually applied this the first time. As I mentioned, the use case method was something we used on Kodak's chemical tracking system project. I was one of the business analysts working on this project, and I happened to work with a number of chemists. That was the user class I was working with. In parallel, we had some other BAs working with other members of other user classes. So I began by asking the chemists to list tasks they would want or need to perform with the chemical tracking system. Each of these became a candidate use case. They said, well, I want to be able to request a chemical or check on the status of an order, view an order, cancel an order, those sorts of things. And I say they were candidate use cases because we have to go back to our scope definition for the project and then see, are these in fact in scope? And if they were, then we said, all right, let's try to learn more about that. So I would prepare a bunch of flip charts like this. We held periodic 2 to 2.5 hour workshops, and this big box here represents a flip chart page, and on each one I would write the name of the use case. Here's a trivial one, view an order. I would write the name of the actor who would have to perform this. In this case, it was a chemical requester. I made a note about frequency just so we could get an early indication of capacity planning and concurrent usage loads and things like that. Now, very often, use cases have certain preconditions or prerequisites that have to be met. This is a part of a use case structure. These are things that have to be true before the system will allow you to actually perform the use case. So these are things the system must be able to test. And we've decided that the system had to contain orders, otherwise it wouldn't be a very interesting query. And during the course of the discussion, someone said, hey, I don't want to be able to see Fred's orders, and Fred shouldn't be able to see my orders. And so we invented a business rule that you may only view orders that you placed, which means there's a new precondition to this use case, that the user's identity must be verified before we can let someone actually use that. So you have to be logged in, for example, so we know who you are, so we can just show you your orders. Now, that's kind of the beginning of a frame of a use case, and then at the end of a use case, certain things are true, and these are called postconditions. And here the postcondition is trivial. The order's been shown. We didn't have any data change. We didn't take any other action or produce any output other than the display. So this is kind of the trivial case. More often there are more complex postconditions. So I like to use Post-it notes for these kinds of discussions. So I set up these two columns, actor actions and system responses. And so I would ask the people in the workshop, well, tell me how you would envision interacting with the chemical tracking system in order to view an order. And someone said, well, I want to enter the order number I want to see. So I'd put that on a Post-it note, that's what the yellow box is here, and put it up. And then I said, well, what should the system do then? Well, if it finds my order and show me the order details then, display the order details. So this is a conversation between the actor and the system, a very trivial one, of course. But you can see how that then satisfies the postconditions. We've displayed the order details, so we're done. That's the whole use case. So that's the normal flow, the happy path. But then you also want to explore alternative flows, other ways that someone might want to explore this. Because someone said, and this is exactly what happened in this workshop, someone said, well, I don't always remember my order numbers, so I'd like to be able to choose an order number from a list. Oh, okay. So we consider that as an alternative way to accomplish the same goal, and that's what an alternative flow is about. And we also have to think about things that could go wrong. So suppose you enter an order number, but it doesn't exist in the system. What should the system do? We need to think about that because unhandled exceptions are a very common source of missing requirements. So we decided very simply, well, we'll just show an order message, order number not found, which is just better than blanking out your entry and waiting for you to do something next. So we would go through this dialogue for all the normal and exception pathways we could think of to try to reach a rich understanding of how this use case might work in practice. then I would go back to my office with these flip charts all covered with Post-it notes after these workshops, and I'd start writing up little descriptions of these use cases, employing a template I'll show you in a moment. And then I would start deriving the functional requirements that we would have to implement in order to make that use case happen. So we would draft our requirement specification. I would also then start drafting test cases, thinking from a different point of view, how would I tell if this was implemented correctly? Often I would draw some models, some analysis models or diagrams to get another view of these requirements. And along the way, from these workshops, we began accumulating some important relevant business rules and building a data dictionary that described the data objects we were going to have to be manipulating with these use cases. Now, the advantage of having tests at this point is that by comparing those to my requirements, I could look for places where I had a concept of a test but no requirement to let it happen, or I had a requirement but no test case to cover that requirement. And so by verifying this document, this textual requirement specification, that's what SRS stands for, Software Requirement Specification, by verifying that just in my mind with these conceptual tests, I found a lot of errors long before I had software that I had to write and then rewrite. I could do the same thing to use the test to verify the models, and at the end of this effort, I had a much better shared vision of what we were going to have when we were done than I ever had before, and that was a pretty good place to end up. Now here's a use case template. You can get that from my goodies page at processimpact.com. I'm not going to go through this in detail, but this is a structure that you can use with little slots where you might store a variety of information about a use case. Now, as with all templates, modify it to best suit your needs. What you don't want to do is just try to fill this out from top to bottom, because that's not how you accumulate information. You populate a template as you accumulate the information, and if you've got an empty box after a while, you say, maybe there's something there we haven't talked about yet. So the term I use when I'm thinking of templates is shrink to fit. I like to think about how to use just the information I need in the template to make sure I can effectively communicate all the necessary knowledge to the people who have to do work based on this use case. So unfortunately, we don't have time to go through all this in more detail right now. But let me just go through a very simple example of a use case for an ATM. This is the kind of thing everybody uses because everyone's familiar with ATMs, and it's a good use case kind of test bed. I started using ATMs as examples in my use case classes long before the first book on use cases was written. So let's talk about the standard one of withdrawing cash, written like a nice use case name there. The actor of interest here is the account owner. A very short description. The user withdraws a specific amount of cash from a particular account. We like to identify a trigger action. What tells the system, hey, somebody wants to withdraw cash? Well, we might have some kind of a menu, and the account owner selects a withdrawal action. So the system now knows, oh, this is what you want to do, but before you do, let me check these preconditions. The account owner must be logged into the ATM. The account owner has at least one account with money in it, and the ATM contains money. I got caught once in a ATM that didn't have as much money as I wanted, and we had problems with that. So these preconditions all have to be tested, and if they're not satisfied, the system will not let you proceed with your attempt to withdraw cash because it knows it can't possibly successfully complete it. Now, here are some post conditions that are probably true. Is you've got the amount of money you asked for, plus we've reduced your account balance by the amount of money we took out, plus any fees, and we'd learn about those fees from business rules. And here's one that's not obvious, is that we've reduced our record of how much money is left in the ATM by however much money you took out. No user will ever tell you that. So simply talking to users is not going to give you all of the requirements information that you need. Somebody else has to know, oh, we need to keep track of this, so the next person's okay. This is a high priority use case because the only reason you put money into the bank is to take money out. So a typical way to write the normal flow is with a numbered series of steps that shows this dialogue taking place between users and the system. So maybe we start by saying the user shows the accounts you have. You choose the account you want to take money out of, maybe your checking account. The system might ask you how much money you want. Here's a list of values. You choose one of those, and it says, fine, here's your money. I can do that. And you take your money out, and you walk away happy. It's the happy path. You're reached your goal, and you're satisfied with the outcome. So a numbered list of steps, and by using the actual name of the entity that's performing each step, I think it's helpful. Instead of just saying user selects desired account, I like to use the actor name because sometimes there's more than one actor involved in completing the use case. So let's try to make that really explicit. We also have to think about alternative flows, and the most obvious one here is that at a particular step, the actor might say they want to enter a custom amount. They don't want to choose one of the amounts to withdraw shown from a list. They want $120, which wasn't on the list. So for each of these alternative flows, you would describe where the branch takes place, how it's handled, and if the alternative flow rejoins the main flow, let's show where that happens. We also have to think about exceptions, all the things that could potentially prevent the user from successfully completing the use case. Now, we might be able to recover from that by re-entering some bad data or something else. But here are some of the common exceptions here that we have to think about. Every ATM I've ever used in my life only contained $20 bills. I know that some aren't like that, but for such an ATM, if the amount you ask for is not a multiple of $20, it's not going to work. I asked for $137 once at an ATM just to see what it would do, and it told me, no, it must be a multiple of 20. There's a rule, a policy, that you can only take so much of your very own money out of the ATM in a particular day, and if you try to exceed that withdrawal limit, that's a business exception that we have to say, sorry, you can't do that. What if you try to take out more money than you have and shouldn't let you overdraw? And what if you ask for more money than is in the ATM? Those are all potential problems, and I'm sure there are others. So in each of these cases, we need to indicate which step in that normal flow where could this exception take place, and how do we handle it? So it's not enough just to think about it, and it's not enough just to hope that the developer is going to think of all these things, because they're not. It's part of the analyst's responsibility to identify these factors and these possible errors and help people know how to handle it so that the developer can implement robust software that really works the way the users expect. All right, so let's close here by talking a little bit about the relationship between use cases and functional requirements. There are really two schools of thought here. Some methodologists regard use cases as being the representation of functional requirements. They regard, therefore, creating a functional requirements list or a traditional software requirement specification as unnecessary. You've already got everything you need to know from a use case. However, I've seen too many organizations get into trouble by relying solely on use cases as a requirements representation. The developers had a lot of questions because a lot of detailed information was missing, so they had to go chase that down, and that can slow down the process in many cases. So I consider that use cases represent the user's view of the system. They reveal the functional requirements that we have to implement. So if we have a user's view of the system in the form of use cases, then the analyst must translate that user's view into a set of individual functional requirements, which gives us then the technical or developer's view of the system. Now, this is documentation. Some people don't like documentation. So if you don't write these out, basically you're relying the developers to derive all of this information on the fly correctly and then pass that along to testers and anybody else who needs to know. If that works in your environment, fine. I never argue with success. But in too many cases, people get in trouble when they do that, and I don't think it's unreasonable to create a shared group memory, particularly when you have people working in different physical locations or different countries and time zones where they don't have intimate communication, to bridge this gap. So I think it's a good idea to try to use the user requirements in the form of use cases primarily to understand the user's needs so that I can then tell developers what we need to build. So that's an important point. So here are some examples of how you might go through the parts of a use case description to get to some understanding of specific functional requirements to allow the correct system behavior to take place. One of the things about preconditions is that if you write a precondition in a use case, it tells you what has to be true, but it never, that I've seen, says what should the system do if this precondition is not satisfied. So we need to figure that out. We need to communicate and derive functional requirements to say, what do you do if a precondition isn't satisfied? So maybe one requirement is the system shall verify that the account is set up for ATM withdrawals, but we would have another one that would say, and what if it's not? What do we do? We look at the steps in the flow, and these are usually pretty straightforward. So maybe something like the system shall display a list of standard withdrawal amounts. The user shall select one of these amounts or other. I'm not saying these are the best of all possible functional requirements. This is just an example of the thought process you go through when you're studying the use cases. Postconditions. We again have to describe the functionality that takes place. So maybe the system shall reduce the total cash remaining in the ATM by the amount of the withdrawal, actually reduce the record of the total cash, of course. So we need to describe the functionality that's necessary to achieve the post conditions for each use case. And we have to understand how business rules affect it. So I've encountered this myself. I have a business account, a checking account, and I have a personal checking account. And I've learned that the system shall print the available balance on the receipt unless the account is a business account. If I go to my bank and make a deposit into my business account, I don't get the balance on the receipt. I have to ask them to write that down for me. So these are just an example of how you might study the use case to figure out what functional requirements fit in. Now, another reason that we might want to write an SRS as well as use cases is because use cases and the functional requirements in an SRS are organized in quite different ways. Here we have these little packages of information for a use case that we saw, the normal flow, the pre and post conditions, alternatives and exceptions, and so forth. And an SRS is typically organized more hierarchically in a different kind of way, where we see that the bits and pieces of information from the use case can end up sprinkled throughout the SRS in a lot of different ways. But it makes sense to the developer to see how these things are grouped together in the SRS. They would like to see a description of an exception or error condition right next to the point in the normal flow where the error can take place, rather than in a separate little package elsewhere in the use case description. So the translation from use case to the SRS helps the developer understand the requirements much better than if they have to figure all that out on their own from most use case descriptions. So I know we've whizzed through this very quickly, and there's a lot more that you can say about use cases if only we had the time. But the reason that I like to employ methods like the use case technique is because it reduces the surprise factor at the end of the project. And my experience has been that surprises in software are generally not good news, and we want to try to avoid that as much as we can. So thanks very much for sitting through this, and now I'll hand the presentation back over to Martin Peterson of RequirementOne for some closing comments.
Well, thanks, Carl. I hope that you've all found Carl's walkthrough useful. Now that you have the process in place, hopefully you're thinking about how you can implement it, and we at RequirementOne would for sure like to be part of that. If you go over to RequirementOne.com and sign up for a free account, we'll run an exclusive training session for you showing how you can effectively apply the use case technique. RequirementOne is 100% web-based. As you can see on the screenshot in front of you, the user interface is real smooth to work with, and the app keeps track of all your requirements and use cases, including associated attributes, any parent-child relationships, and on top, it also logs any change made automatically. It's pretty nifty. So I suggest that you go to RequirementOne for your free trial, and we'll talk to you soon. And now that I'll hand you back to Carl for Q&A.
Okay, how do you cater for reusability when something isn't a standalone use case? For example, enter a password wouldn't be considered a use case. It isn't a business objective, but it is something you might have to do as a part of several different use cases.
Absolutely it is, and the way that usually works then is to treat that as a precondition. So very often when you go to, say, a website, there are certain things you can do without being logged into it, and there are certain things you must be logged in to do. Like, I can search for flights at an airline's website without having to be logged in, but if I want to see my frequent flyer mile status or make a reservation, I have to be logged into my account. So typically that would be handled in the form of preconditions that you would have to say, okay, user is logged in or authenticated or however you want to say it, and then you would have this, the associated functionality. It'd still be part of your requirement specification, everything you need to do about logging in and authenticating users and locking people out if they tried the password 4 times and failed. All that kind of stuff is definitely functional requirements, but I would not put it in the form of a use case, partly because I already know about it, and my goal is to employ use cases to discover that kind of knowledge, and partly to facilitate the reuse. So you'd write those requirements once, and then in the use case descriptions, you would just identify the need to be logged in as a precondition.
Right. Okay, well, we'll do 2 more questions here. One is there a way or methodology to find out the level of detail necessary to include in a use case?
I don't think there's any methodology for that, but I think there's a lot of judgment the business analyst has to do. And one of the problems that we run into is that the BAs do their best to write requirements in any form in a way that's going to meet the needs of the audience, but too often we don't sit down with the developers or the testers and say, what do you need from me? What's the best way to organize this? How much detail do you need? So let's make this very collaborative. Let's have the BAs work with the developers and the other consumers of the requirements, the victims of the requirement specs, let's have them sit down together and try to reach an understanding of how much detail we need, and also how to represent the information, how to structure and organize the documentation. In general, I would say that if you're doing something familiar, if you're doing something that people have done before or variant of that, something straightforward and relatively simple, then you don't need as much detail as if you're doing something that's complex or has a lot of failure modes or has high-risk failure modes and that sort of thing, where you really do need to have a lot more detail associated with it. And also, you don't need to have as much detail if you're sitting right next to the developer who's going to be implementing it, and you can answer questions in real time. But if you're going to be mailing this to somebody 4,000 miles away, you better have a little more detail. So there's a lot of judgment and context that goes into that decision.
Okay, last question here. As you go through the elicitation process and uncover business rules related to your use cases, what would be a good way to keep track of those business rules and relate them to specific use cases that or steps that they apply?
That is an excellent question, and that's something that a lot of organizations are very casual about. They sort of treat their business rules at about the level of cave drawings that we see on, walls in France. And really what you need to do is build a business rules catalog, and that can be either a very elaborate thing that you put into a business rules tool. There are commercial tools to help you store and manage your business rules, or it could simply be a list that you start in a Word file or an Excel file or something, where you begin in a very simple template to capture those business rules, because very often business rules have an existence outside the scope of a particular project, and they will affect multiple projects. They exist whether or not you even have software in many cases. And so you need to start capturing those separately from your requirement specifications for a project. But if you label each of those business rules, you give each one of those a unique label wherever you stored them, now you've got a way that you can cross-reference to that. So in the business rules section of my use case template, I'm not going to actually state the rule. I'm going to state the identifier on the rules that are pertinent to that use case. And in fact, you can use hypertext. So wouldn't it be great if I'm looking at a use case template and maybe in a Word document, and it says, okay, business rule 27 applies here, and I could just click on that and jump into my business rules catalog, and there's business rule 27, and every place I need to know that information, I can just link right into it. So that's the best way to handle it, and that's a very important question.
Awesome. Well, thank you, Carl and Martin, for a very informative presentation. Thank you to everyone for attending today's Modern Analyst webinar. I wanted to point out that the webinar, along with the slides, will be archived at ModernAnalyst.com within a few days. And this concludes today's event, so we hope you have a great day.
Thank you. Bye-bye.